You know, when you plug in your phone at night, have you ever really stopped to think about where that power comes from? I mean, we just take it for granted, right? But behind that simple act is this incredible, globe-spanning system that we rely on every single second of the day. So today, let's pull back the curtain and take a look at how it all works.
So, let's just ask that question straight up. When you flip that light switch, you're plugging into this massive, incredibly complex grid. But what is actually at the other end making that power? Well, the answer, it might actually surprise you. Okay, so check this out. This is a breakdown for the UK. We hear so much about green energy and renewables, but look at the reality. Almost 80%, yeah, 80% of our electricity is still coming from non-renewable sources. To put that another way, for every 5 times you turn something on, 4 of those times it's being powered by something that will eventually run out. We are still very, very reliant on the old guard of energy.
And that right there brings us to the most important idea for understanding all of this. It's this great divide between renewable and non-renewable energy. Basically, every single way we generate power falls into one of these two buckets. You've got things like solar and wind on one side, and then you have coal and nuclear fuels on the other. It's as simple as that.
So what's the difference? It all comes down to this. Renewable energy sources, well, they replenish themselves. Think about it. The sun keeps shining, the wind keeps blowing. But non-renewable sources, they're finite. There's only so much of it in the ground, and once we've used it up, it's gone, for good. So let's start with the stuff that's been powering our world for the better part of 200 years, the non-renewables.
The big three here are oil, coal, and natural gas. We call them fossil fuels, and they're basically just ancient, compressed sunlight. I mean, think about it. They're hydrocarbons, formed over millions and millions of years from the remains of dead plants and animals. All that energy just locked away underground. But, and this is a huge but, they come with some serious problems. When we burn them, they release huge amounts of carbon dioxide, which is a major driver of global warming. Burning them can also cause acid rain. And of course, there's that fundamental issue we already talked about. They're gonna run out eventually.
Now, the other major player in the non-renewable camp is nuclear fuel. This usually means using an element like uranium, which is an absolutely incredible, super concentrated store of energy. We unlock that power through a process called nuclear fission, which is basically a fancy way of saying we split atoms to release a tremendous amount of heat.
And nuclear really shows you the kind of trade-offs we're dealing with. On one hand, nuclear plants produce zero CO2 while they're running. That's a massive win. And the fuel is pretty cheap and powerful. But on the other hand, the cost to build one of these plants is astronomical, and you're left with radioactive waste that has to be stored safely for hundreds, even thousands of years.
So, when you think about the environmental costs, and the fact that the old guard is running out, where do we go from here? Well, let's take a look at the challengers. This brings us into the really exciting, fast-moving world of renewable energy. First up, wind power. You know, the idea here is just beautifully simple. The wind pushes against these giant blades, making them spin. And inside, a generator turns that motion, that kinetic energy, into electricity. The pros are obvious, right? It's totally renewable, no carbon emissions. But the big catch is reliability. If the wind isn't blowing, you're not making any power. End of story. Not to mention, some people think they're noisy and just don't like the way they look on the landscape. Next up, solar. And the tech behind this is just amazing. These panels are made of what are called photovoltaic cells, and they have this wild ability to take sunlight and convert it directly into an electric current. There are no moving parts, it's just sunlight in, electricity out. Solar is a lifesaver for remote places that aren't hooked up to the main grid. But just like wind, it completely depends on the weather. If it's a cloudy day or nighttime, you get nothing. And to generate a serious amount of power, you need a huge area covered in panels. All right, hydroelectric power. This works on a totally different idea. You build a massive dam to hold back a river, creating a huge lake or reservoir. All that water, held up high, has an incredible amount of stored energy, what we call gravitational potential energy. Then you let it flow down through turbines, and as they spin, they generate electricity.
So the huge advantage with hydro is reliability. It's clean, it's consistent, and you can turn it on and off really quickly to meet demand. The downside, though, it can be devastating. Building a dam floods vast areas of land, which can wreck ecosystems and force entire towns and communities to move. Geothermal is pretty cool. It taps into the heat that's already deep inside the earth.
In certain places, usually volcanic areas, we can pump water way down where it hits super hot rocks. It flashes into high-pressure steam, rushes back to the surface, and spins a turbine to generate power.
And it's an amazingly clean and reliable source of power. I mean, the Earth's core isn't cooling down anytime soon. But here's the catch. Its biggest limitation is geography. You can only build these plants in a few very specific spots on the planet, where that heat is close enough to the surface.
And finally, we've got biofuels. These are fuels made from organic stuff. Think plants like corn or even animal waste. The idea is that they can be carbon neutral because the CO2 released when you burn them is the same CO2 the plants sucked out of the atmosphere while they were growing. But there's a pretty big debate about whether that's truly the case, especially when you factor in all the land and resources needed for farming.
So as we've gone through all of these, from fossil fuels to nuclear to wind and solar and everything else, you start to see a pattern, right? Every single option has its own unique set of pros and cons.
And that really leads us to the big takeaway here. There is no magic bullet. There's no one single perfect source of energy that's going to solve all our problems. The real challenge, and honestly the most likely path forward, is figuring out the right strategic mix. We have to combine all these different sources to create a system that's reliable, affordable, and sustainable 24/7.
It is an incredibly complex puzzle, and the stakes for our planet and for our way of life couldn't be higher. So that leaves us with the ultimate question. What combination of these sources is going to power our world tomorrow? What do you think the right mix is for our future?